This is the lecture that goes along with these slides for Chapter 13 Geodatabases. So what are geodatabases? They're designed to store feature classes for a particular geographic area. It incorporates all feature classes, rasters, and tables into a single entity. There are three primary types of geodatabases: personal, file, and SDE. Personal ones are stored in a Microsoft Access database. They're for single users or small working groups. They have a 2 GB size limit. Only works with Windows. File geodatabases is basically stored in folders. They're for single users to small and large groups, up to 1 terabyte in size. Their cross-platform operability allows this to be used in Windows or Unix or Linux. And there's SDE geodatabases. These are stored in these large commercial relational database management systems like Oracle and SQL Server. They're designed for multiple simultaneous users. It supports this. It allows versioned editing, but it does require a special license and an ARC SDE license to translate back and forth. What goes in the geodatabase? Feature classes and feature datasets. Feature dataset is a collection of related feature classes. You can also put in tables and annotations and relationships like formal persistent joins. You can put in planar topology classes and the rules for how these classes interact spatially, as well as network topology classes, which enables modeling and analysis of network features. Here are the layout of what these things look like in catalog. Functional applications. Geodatabases support a variety of data management functions to enhance work. Domains and subtypes, planar topology and spatial rules, network topology and connectivity, relationship classes, and versioned editing. And so we'll talk a little bit more about these. Domains. Domains are rules about what can go in an attribute field, and it reduces data entry and consistency errors. So for example, if you have a coded domain and you have a set list of allowable values, for example, say you have an input field of pipe sizes, a 1 inch, a 3 inch, a 6 inch, or a 12 inch, you can literally use a coded domain of 1, 3, 6, or 12, and then a description box would populate based on the code you put in. 1 would then give you a description of 1 inch, 3 would give you a description of 3 inch. Instead of typing in those things and having little things like, is there a space before or after the dash between 1 and inch? Spelling mistakes, mistakenly hitting an extra number like 33 or 11 instead of 1 or 3. It eliminates all that because you can only put in answers that you have previously said could be a possible answer. Then there's also range domains. These set ranges of allowable values. For example, if you're recording an entry of a percentage, then you can say it has to be between 0 and 100, and that eliminates any mistakes or improper entries. Subtypes are another one. Subtypes are integer-coded classes of features. They automatically display with different symbols. They behave as different layers during editing. Each subtype can have its own default values and it streamlines attribute entry. In other words, in a network of roads, you can classify the roads based on their subtypes. Planar topology in Chapter 12, we covered this a good bit, about setting up rules like no overlaps, no gaps, etc. These are also things that you can establish and enforce in a geodatabase. Network topology. Networks create networks to analyze things like traffic, utilities, and various connectivity rules. Things like a 12-inch pipe connects to a 6-inch pipe only if it goes through an adapter. And so if you code in a section of, say this is 12, and the next one you code in a 6, it'll flag it as an issue with the topology because you can't go from a 12 to a 6 unless you put in a connector node to resize that or adapt it. Versioned editing might possibly be the best thing since sliced bread. Imagine how hard it was to make a sandwich when you had to tear off your bread in slices instead of slicing it. Anyway, it allows multiple people to edit geodatabases at the same time. It can resolve conflicts between the different edited versions that people create. It allows you to test a lot of what-if scenarios, like what would happen if we changed this topology rule, etc. The best part is you can roll back to a previous version in the case of failures. So what if all the things you've done previously today just pretty much destroyed your database? You can just go back to yesterday. A schema. A schema is a full description of all the features, classes, tables, fields, topology, and relationships in a database. They may be grown through time as databases are haphazardly assembled. They may be designed ahead of time to fulfill specific organizational needs. They can be downloaded, shared, or customized. Think of it as a plan or a table of contents for a geodatabase. In other words, what is this geodatabase for? What does it contain? That's what a schema is. This is what they can look like. This is a couple from the San Bernardino County GIS, explaining what is in their geodatabases. When you look up close, you can see a lot more detail about how things are set up and structured. Creating data sets. Woohoo! Designing a good geodatabase. Define the purpose. Talk to users about the needs. Define the geographic characteristics, in other words, the area or the extent that it settles for, or suits for, or is designed for. The scale, the projection. List and organize feature classes and rasters. Define the schema, the fields, the domains, the subtypes, all those things that go into the various components. Plan out your metadata and how you're going to do that. For long-term projects, develop a schedule for creating and updating your data as well. Organizing feature classes, you want to keep similar features in the same feature class. Easy to separate things that are together, but it's not so easy to put things together. And so one feature class with the highway type fields can be symbolized by the fields you can query and clip out just the parts that you want. Much easier than you can take individual different types of data layers for roads or highways and put those together into a single feature. How do you create one? Well, in catalog, find the folder you want, go to new, and then go to create file or personal geodatabase. It's just that simple. There's also tools and toolbox and workspace to create feature data sets, file geodatabases, folders, and personal geodatabases. Once you create one, you can import things in, like single classes. There's also feature class to feature class tools that allow you to copy things basically from one location and add them into another. You can select subsets of information using a SQL expression. There's all kinds of different ways you can do this. One thing that would be helpful, you could do something like this and have coordinate systems that are different, but they can be automatically projected from one feature into the new feature class in the new geodatabase. And so you can use this as a means of changing the coordinate systems on a lot of data smoothly. So how do you create new feature classes? You find your geodatabase in catalog, right click, go to feature class. Give it a name. You can then assign the various coordinate systems for it. You can import those from the known standards that we have, adopt from a known standard. You can import them from another layer. You can set various tolerances. You can enter any values that you have to for the things that you're doing. And then once you're done, hit finish. Featured data sets, like we mentioned earlier, they are related to feature classes. They have a common coordinate system. They may participate in topological relationships and networks. Keyword there is may. They don't have to, but they can. Coordinate system, every feature class has a feature data in a feature data set must have the same coordinate systems. So if you have a feature data set that has various polygons of habitat based on species, they all have to be in the same coordinate system or they can't be part of the same feature data set. The coordinate system is designed during the creation of the feature data set. You can import imported and created feature classes will automatically be projected in the feature data set coordinate system. So how do we create feature data sets? Same way, geodatabase, new, feature data set. How do we use geodatabase features? We're going to look at domains, split and merge policies, and subtypes. How do you set up a domain? I called GoDaddy to set up my first domain. I'm kidding. Domains are basically rules for data entry. They prevent typing errors. They can verify that values fall into a correct range. So you can make it like it has to be a text answer. It has to be one of these 5 answers. It has to be an answer within this range. They're created for entire databases, and they can be reused in different feature classes. Code and range, talked about those a little bit earlier. What are some of the issues? Save space by storing numeric codes, but set up domain for easy interpretation of values. Yeah, makes it easier and quick to put stuff in, and then it automatically translates it. Coded domains, always enter the descriptions even if they're identical to the code. Users only see the descriptions when you put the stuff in. So in this example, you have a domain name like diameter, and it tells you what it is. So you enter the domain name and description in an empty row, set up a domain type in the field, set any split and merge policies that you have, and then you enter the code for the matching description. To add one, similar, just follow these directions. It's very important to be sure to click apply after each domain is entered. Why, you might wonder? Well, if you entered several before clicking apply or OK, and one of the domains contains an error, it's really hard to figure out which one has the problem. So usually you end up deleting all of them and starting over. So if you check after each one, you'll know if something's wrong. Domains are assigned to one or more fields. They may be assigned when the field is created, or you can go in and assign them later. Domains must be assigned to fields of the same type. In other words, if it's a short integer field, you can't use that for a long integer domain. A float field can't be used for a double domain. They have to match up. So if it's an integer field, it has to have an integer domain. Assigning domains to fields must be done in catalog. You highlight the field, you click on the properties, you do what it says, and that's pretty much how it works. Domains are most visible when you're editing stuff. Coded domains field in the table contain a drop-down box instead of allowing the users to type in data. That can be very helpful. Range domains does not warn you automatically when you enter a wrong value. There's no impact on you until you perform a validation. So just like checking any kind of topology, when you check to validate entries, if things exceed the ranges on a range domain that you have in place, it will identify that. Records falling outside of it are flagged for further editing. How do you edit coded domains? Coded domains show up as drop-down boxes when editing in tables or attribute editor. Users select the desired values. If you forget to enter the description when you set up the domain, the values to choose from will appear blank. Editing range domains, type in normal values normally. You type in the values normally. Range domain do not automatically warn you if you enter something that's outside of it till you perform a validation, just like we said in the last slide. And then if something's wrong, it flags it for editing. And so you would do this process, go to editor, validate features, and then tell it which ones, and then it will identify the problems. Split and merge. When polygons are split into pieces or merged together to make a single new polygon, the attributes have to be updated. Depending on the type of attribute, different treatments are appropriate. You can copy new one, like something like land use codes. You can leave it blank if it's like parcels for an ID number. You can partition or sum based on area, so you have a value, say population. You split a polygon up, 60% on this side, 40% on that side, then you take the population, 60% goes to the 60% side, 40% goes to the 40% side. Split and merge policies control the behavior of features, attributes. Split and merge policies control the behavior of features, attributes when the feature is merged or split. In other words, it controls what happens to those things when you do these functions. It saves a lot of tedious re-entry for every attribute and it prevents inappropriate assignment of data incorrectly. Merge policies reduce data entry tasks when features are changed. It does things like weighted averages and sums and defaults. Any number of ways you can do this, but when you bring things together, you have to tell it what to do when it has different data. Merge policies are included in ArcGIS for consistency with other databases. However, they do not actually work in the editor. Instead, the user selects the feature that defines what the merged feature attributes will be. Split policies reduce data entry when features are changed or duplicated. Deals with things like geometric ratio and its default. Subtypes. I like a good Italian. Every once in a while, I'll have a club. Old standbys or turkey and roast beef. That's my subtypes. Integer-coded classes of features within a single feature class are what integer-coded classes are. Subtypes are based on a short integer field in the table that stores a numeric code. The description is then added to display for display and interpretation, and it's what the user sees. So how do we use these defaults? You automatically assign the default values to features when you're editing or digitizing. What are the advantages? Each subtype can have its own default types, its default values. Each subtype is treated as a separate layer during editing. And if you have an ArcGIS standard license, then each subtype can have its own set of validation rules. And each subtype can have its own topology rules as well. Some examples of subtypes. More about editing. When do you use subtypes? When a feature class has a limited number of clearly delineated types, when setting different defaults for each type is useful, and when the topological or network behavior of each type is different. So let's apply this concept theoretically to roads. So when the number of types of roads is clearly identifiable, primary, secondary, highway. When it's useful to differentiate between these types, let's see. Yeah, that's useful. And when its topological or network behavior of each type is different. Primary roads don't handle a lot of traffic. Secondary roads handle even less. Highways tend to be one directional, split apart with the east and west or north and southbound lanes. And they have a lot more traffic load. So yeah, they behave very differently. Typically, you don't have a lot of intersections on highways. They tend to just be one directional. They have entrance and exit ramps. So step one is you plan out the subtypes. This is important. First, plan. Figure out what all the properties are that you need for each of your classes, what subtypes you're going to use, are they complete. List out all the attributes and all the domains and all the split and all the merges and everything that you have to have so that you know what it should look like. Then set it up. For example, waterline features. Is it a main? Is it a lateral? Is it a sewer main or is it a sewer lateral? What are the attributes for each of the water lines? Is it a pipe diameter? Is it pipe material? Is it installation data? Is it maximum flow? Are these domains for the geodatabase? Are they coded like diameters 3, 4, 6, 8, 12, 14? Is the material coded? Copper, PVC, lead, steel, concrete, tile, other? Is things like flow in a range 0 to 2,000 gallons per minute? Create the domains. Open your geodatabase properties, create them, and remember to apply after each one. That way if something's wrong with the one you just put in, it'll let you know. Then you go create your feature classes. You can use the data management tool to create them. You can add all the fields in. You can create all the types, subtypes, defaults. Different default values can be specified for each subtype. It saves a lot of editing, although there may be exceptions to the default for old subdivisions have, like, for example, lead laterals that you might have to edit. Overall, editing is reduced by setting up the defaults. Each of the attribute fields may then in turn have its domain. So you set all those up as well. Run everything, do a little bit of editing, clean up some mistakes, fix up some little problems here and there. And you save a ton of typing for all these things. Editing annotation. Do you remember what annotation is? If you don't, annotation will be very disappointed. Annotation in Chapter 3, way back when, you learned to create annotation and save it to a map document. Now, in this chapter, we're going to learn to create and edit it in a geodatabase. Annotation is basically a label that acts like a point value. So the first thing you do is go into your layer properties and create dynamic labels. And then you go into your table of contents and you go down to convert labels to annotation. And so initially you would get something that looks kind of like this. Now you can edit it in editor right next to the little black arrow key. There's with an A under it. This edits annotation. You can click on the roads template and choose the construction tool and type in the text and do whatever you need to do. So what do the construction tools do? They make things line up horizontal or vertical or straight, or follow the feature, or come off of it with a leader, or curve along things. You can also use it to move and delete things. So you've got 50 cities and you only wanted 6 of them. What do? You take all the labels, you make them into dynamic labels, you convert it to annotation. You select all the ones you don't want, you delete. They're gone. Annotation has handles with various functions. Click and drag the handles to achieve the desired result. In other words, you can shrink it and enlarge it, you can move it, or you can rotate it. There's also an ability to edit the attributes of annotation. So it has the same kind of a window. It has additional tabs. You can set the font size and the symbols, etc. And the selected annotation appears in the window, and that's how it's going to look. So you can see where it's at, what it does. You can change all the things and see what it's going to look like. So ways to create it: for horizontal, you can click on the map and place it. For straight, you can click on one of the anchor points, and again, to establish an angle. For a leader line, you can do that, and then you can tell it to follow the feature or to curve. If you have an existing one and you want to make it follow, simply select it with the annotation tool. Right-click on the feature that you want to follow, and then click the Follow This mode. Click on the center of the annotation and drag it until it's in the desired location, and then click to place the text when you're satisfied with it. You can stack things for better fit. And so what does that mean? Well, if you right click it again and choose unstack or go back, it'll unstack it. Stacking means you have a really long name like Rapid City Regional Hospital, and you want it to say Rapid City on the top line and Regional Hospital below it. It allows you to stack that. More editing. There's techniques for editing annotation. This basically just gets you started with some of the things that you can use that could be helpful.